I'm presenting a problem involving Sklearn's least angle regression, Lars, model. We're predicting house prices using features like square footage, number of bedrooms, and location. After fitting the model, we see that the coefficient for size is very small, around 0.001. We need to determine what this suggests about the model and the data. It's a bit of a detective story. Let's find the clues. This option suggests that size might be highly correlated with another feature, such as living area. If that is the case, least angle regression might favor one feature over the other, resulting in a near zero coefficient for one of them. Think of it like this: if you have two almost identical features, the model might only use one of them to avoid redundancy. A coefficient close to zero means the feature doesn't really help to predict house prices. In simpler terms, the model is saying that size is not a big factor in determining the price. The regularization parameter, alpha, in Lars controls how much we penalize large coefficients. A large alpha value will pull the coefficients towards zero. So, setting it too high could explain why the size coefficient is so small. We're essentially telling the model to prefer simpler solutions, even if it means losing some predictive power. While this is possible, it's less likely to affect only one coefficient. Premature convergence usually impacts multiple coefficients. I find it more likely that other factors explain the near-zero coefficient for size. I'm presenting a scenario where you're using least angle regression, Lars, a type of linear regression from Sklearn, to predict house prices. You have features like house size, number of bedrooms, and location. After training the model, you see that the coefficient for size is incredibly small, about 0.001. Now, I want you to tell me which statements are most likely true given this observation. We'll explore the reasons behind this result together. This statement could be true if size is strongly related to another feature. Maybe living area. Lars might favor one feature over the other. The algorithm might choose one and essentially ignore the other, resulting in a near-zero coefficient for the ignored feature. This is highly likely. A coefficient very close to zero means that the feature, size, isn't contributing much to the prediction of house prices within this specific model. This is less likely to be the main reason for just one coefficient being close to zero. Premature convergence usually affects multiple coefficients simultaneously. A high alpha value means that we're applying a strong penalty to large coefficients. This pushes coefficients toward zero, making this a likely explanation for the small size coefficient. Think of it like this: a high alpha is like saying, I want to keep the coefficients small, even if it means sacrificing a bit of accuracy. A coefficient near zero for size tells me that the model found size to be a weak predictor of house prices. It doesn't significantly help the model predict prices. Think of it like this: the model is saying, size? Meh, not really important here. If the Lars algorithm stopped too early, it might not have fully explored all the relationships between the features and house prices. This could lead to inaccurate coefficients, including a coefficient near zero for size, even if size is important. But it's less likely to only affect one coefficient. Alpha is a regularization parameter. A large alpha value penalizes large coefficients. It essentially shrinks coefficients towards zero. So, a high alpha could be why size s coefficient is small. The model is being too cautious and underemphasizing the feature. Think of it like a too strict teacher penalizing a good student. I see, you're asking about interpreting a near-zero coefficient in a Lars model. Let's break down what that means. A coefficient represents the impact of a feature on the prediction. A small coefficient means that that feature's impact is pretty minimal. That's what we're trying to understand here. Okay, we're dealing with a specific situation, using Lars to predict house prices, and the coefficient for size, in square feet, is super tiny, almost zero. We need to figure out the possible reasons. I want you to understand the context here. The core algorithm we are using is called least angle regression, Lars. It's a clever method that builds a regression model step by step, adding the most important features. It's really good at feature selection. We're going to examine the resulting model's diagnostic information. This is very likely Imagine size is strongly related to living area. Lars might pick one and downplay the other, resulting in a near zero coefficient for one of them. This is the essence of multicollinearity. Features are essentially duplicating information. That's a direct interpretation of a small coefficient. If the coefficient for size is near zero, it tells me this variable is not a good predictor of house prices in this model. Lars uses a regularization parameter called alpha. ALPHA controls how much we penalize large coefficients. A large ALPHA shrinks coefficients towards zero to avoid overfitting. So, a high alpha can result in coefficients being unfairly minimized. Although Lars could stop early, that would usually impact many coefficients, not just one. It's less likely to be the only cause of a single near zero coefficient. I'm analyzing a model's results. Lars, or least angle regression, is a method used to build a linear model. Diagnostics here means examining the model's performance and understanding what it tells us about the data. We're looking for insights into how the model is working. We are given a Lars model used to predict house prices, and we're looking at the model's coefficients, numbers showing how each feature affects the prediction. This tells us the context of the problem. We have a real-world prediction task and we're using the Lars model to solve it. This is the core of the quiz. We need to identify which statements make the most sense given the model's results and the nature of Lars. We will check the validity of the given options. This suggests that size might be redundant because another feature already captures similar information. This is a common issue in statistical modeling. This means that size doesn't seem to help much in predicting house prices in this specific model. The coefficient near zero supports this. This means the algorithm stopped too early and didn't get a chance to fully find the best fit. This can lead to less accurate prediction, affecting various variables. The alpha parameter controls how much the model shrinks the coefficients towards zero. A high alpha can punish large coefficients, causing the coefficient for size to be close to zero. We are penalizing model complexity. This is a form of regularization that helps prevent overfitting. This is the instruction. You need to pick all the options that seem to be valid based on your understanding of the quiz context. We're investigating why the coefficient for the size feature in our house price prediction model is very close to zero. This is the core of our problem, and we'll examine several potential causes. I think that size, meaning the square footage of a house, might be highly correlated with another feature in the dataset, like living area. If these two features are almost the same, the model might prioritize one, leaving the other with a near zero coefficient. A coefficient close to zero suggests that size doesn't strongly influence the prediction of house prices in this particular model. The model has essentially deemed it unimportant. The regularization parameter, alpha, controls how much the model penalizes large coefficients. A high alpha value shrinks all coefficients towards zero. This could explain why the size coefficient is so small. The model is overly cautious about giving any single feature too much weight. We'll explore these possible reasons for the near zero coefficient to determine which are likely correct. Think of it like a detective story. We're investigating the clues to understand what happened. This is a multiple-choice question, designed to test our understanding of the factors affecting the coefficients in a linear regression model and specifically how least angle regression works. This is the question which asks us to consider all of the explanations together and select those which are most likely to be accurate. Lars, short for least angle regression, is a sophisticated technique used to predict house prices based on input features like square footage and the number of bedrooms. I see a coefficient near zero. That tells me the size feature isn't a strong predictor of house prices in this specific model. A near zero coefficient means that the model is not using the size variable much to make its predictions. Think of it like this. The model is saying, size isn't very helpful in guessing the price. While Lars could stop too early, that's unlikely to make only one coefficient nearly zero. Usually, if Lars stops prematurely, multiple coefficients would be affected, not just size. Lars uses a regularization parameter called alpha. A high alpha value makes the model prefer smaller coefficients. It's like adding a penalty for large values. If alpha is too high, it could shrink the size coefficient toward 0, even if size is actually important. The coefficient close to 0 strongly indicates that the feature is not a significant predictor of the target variable, house prices, in the model. The model found it not very useful for price prediction. If size is strongly related to another feature, e.g., living area, Lars might pick one and essentially ignore the other. The ignored feature will have a coefficient close to 0, even if it has some predictive power on its own. It's like choosing one feature over another very similar one,